Okay, so the next section that you are going to see, friends, is about shapes. Primarily here we talk about the volume and the area regarding the shapes. And if you talk about shapes, there are two forms of shapes. One is the two-dimensional shapes, which primarily has the area as well as perimeter, and the three-dimensional shapes, where you add one more dimension, which is about the volume. So the next series of questions that you are going to solve is about how to find perimeters, how to find the area or the differences in area, differences in volume, and so on and so forth. So we will take 2-3 examples and get into the details of this segment. A metal sheet 27 centimeters long, 8 centimeters broad, and 1 centimeter thick is melted into a cube. The difference between surface areas of two solids is option A 284 centimeter squares, option B 286 centimeter square, option C 296 centimeter square, option D 300 centimeter square. Okay, so you would have seen the problem statement where it says that you have to convert a metal sheet into a cube. In mathematical terms, the metal sheet is nothing but we call it as a cuboid. So let's look at how the dimensions as mentioned in the problem looks like in a cuboid. So this is a cuboid. So it has got length. In the problem it is shown as 27 centimeter, right? It has got a breadth which is shown as 8 centimeter, and it has got a thickness. The thickness is shown as height, let us put it as height, and it is shown as 1 centimeter. Okay, that's the dimension that is given for the cuboid. Now what the problem says, which is where you should be very careful, is that it is being converted into a metal cube. The assumption that we can safely make is that when a piece of metal is converted from one shape to the other shape, if unless otherwise stated, it is to be assumed that the volume remains the same. Okay, so this has been converted into a cube. So how does a cube look? Cube is a fairly simple shape because all the sides of it will remain equal. Now there are two terms that has been mentioned in the problem statement which talks about volume and surface area. Okay, so for a cuboid, how do you define the volume? You should be knowing the formula of it. It is L into B into H. In this case, it has to be 27 into 8 into 1, which translates into 260. Now let's look at the surface area of the cuboid. Surface area is actually the area of any shape is the length into breadth, and for any shape like this, be it a cuboid or a cube, it has got 6 faces of it, so it has to be multiplied. And in a rectangle, as you would know, it is length into breadth, breadth into height, and height into length. So it is nothing but 2 into LB, that is length into breadth, plus length into height, LH, plus height into breadth, right? That's how the surface area of a cuboid is made. So let's do the translation. 2 into, that is 27 into 8 plus 27 into 1 plus 8 into 1. Okay, this is the calculation involved in the calculation of a surface area of a cuboid, which comes to around 502 centimeter square, right? So these are the two important things about the cuboid that was in the first shape, that is a thick metal sheet. Now it is being converted into a cube. Now cube also, it says that the volume remaining the same, which means for a cube all the sides of the cube will remain as same, which means let's say that the side of a cube is A. If the side of the cube is A, let me use a different color for you. So A is the size of one of the sides, and the volume for a cube will be A into A, which is given to be equal to the volume of the cuboid, that is 216, right? So which means a cube is equal to 216, and that means a has to be cube root of 216. Okay. Now what is cube root of 200? I'm rubbing this off, keeping the surface area part as it is. The cube root of, so going back, a is equal to 216 cube root, which comes to around 6 centimeter. Okay. So one side of the cube is 6 centimeter. Okay. Now we also know that the surface area of the cuboid has been 502. Let's remove all this and retain only the surface area of cuboid. Now surface area of the cube will then be, same formula if you apply for a cube, it becomes 6a square. Okay, know the value of a, so you substitute it with 6 into a square, that is 36, which comes to around 216, right? Now you have the surface area of the cuboid here, you have the surface area of the cube here. Now it becomes simple calculation. So the difference in surface area, I'm just putting difference in surface area is nothing but 502, which is the surface area of the cuboid, minus 216, which is the surface area of the cube, and the resulting answer will be around 286 centimeters. The perimeters of two squares are 68 centimeters and 60 centimeters respectively. Find the perimeter of the third square whose area is equal to the difference of the areas of these two squares. Option A 64 centimeters, option B 60 centimeters, option C 32 centimeters, option D 8 centimeters. Okay, so the problem statement here is that we have been given the perimeter for two squares and we are asked to find the perimeter for the third square. Okay, and there is an equality statement which says that the difference in areas of the first two squares is equal to the area of the third square. Okay, so let's try to draw the details of it. So there are three squares. Let's call the side of one of it as A1, the other one is as A2, and the third one is of A3. Okay. Now the perimeter of the first one is given. So the perimeter for the first one, let's call it as P1, is given to be 68, right? So P1 is 68, which means the perimeter, the formula for perimeter is nothing but 4a. Now if you apply the 4a formula for the P1, which becomes 4a1 is equal to 68, and thus a1 is equal to 68 by 4, okay, which is 17 centimeters. Alright, so A1 is 17. Now let's go to the A2, which is corresponding statement given as the perimeter of the square 2, which is given to be 60 centimeters. Okay, that means 4a is equal to 60. In this case, it becomes 4a2 is equal to 60, and thus A2 is equal to 60 by 4, which is 15 centimeters. Okay, so A1 is 70 and A2 is 50. Now we have been given that the equality statement says that the area, the difference in area of A1 and A2 is equal to the area of A3. Okay, now A1 and A2 is given, so the area of a square area as per the formula is a square, right? So apply the same thing. So for the square 1, the a is equal to a1, which means it applies as 17 square, which is equal to 289 for square 1, and for the square 2 it is 15 the whole square, that is 225 square centimeter. Okay, centimeter square, okay. That's the area of these two squares. Now what the problem says is that the difference in area is the area of the third one. That means So the third one, A3 square is equal to the difference in area, that is 289 minus 225, okay, which is 64 centimeter square, okay, which means the side of the third square, that is A3, is square root of 64, which is 8 centimeter, okay. Now the question is, what is the perimeter of the third square? That is, perimeter thus is equal to 4 times the side, which is A3, which gives 4 into 8 equal to 32 centimeter. So the option which shows 32 is the right answer. A garden is 90 meters long and 75 meters broad. A path 5 meters wide is to be built outside around it. Find the area of the path. Option A, 6150 meter square. Option B, 8500 meter square. Option C, 1750 meter square. Option D, 5200 meter square. Okay, the problem statement suggests that there is a garden which is of certain length and certain width, and then somebody is planning to draw a path around it. So the question is, what is the area of the path? So let's try to work it out. Okay, so assume that this is a garden. Okay, the garden's length is 90 meter. So let me draw it inside. I'll tell you why. Let's do it 90 meter, the length, and 75 meter is the width. Okay. Now, somebody wanted to build a path around the garden. Obviously, garden needs to be used by people and without stepping inside. So they wanted to build a path. So let's draw it in a different color. So they are building a path around this in the same rectangular form. Okay. What it says is that the width of the path is 5 meter. Okay. And the question is, what is the area of the path? So the area of the path is nothing but this shaded area. This is what we need to find out. Easier way, very simple question. Find the area of the outer rectangle. Find the area of the inner rectangle, take the difference, and that's the area of the path. Okay, so what is the dimensions now? The inner rectangle, which is the one which is given. So the inner rectangle, length 90 meter and breadth is 75 meter. So the inner rectangle area is equal to 90 into 75 meters, which comes to 6750. Now, what is the external rectangle? So we have been given that the 5 meter is the width of the path. So which means both sides you need to add. This is where normally we make mistakes. This is 5 meter added to the outside, which means 5 meter plus 5 meter is being added onto the length, as well as 5 meter plus 5 meter added to the breadth. Okay. So the outer rectangle looks like this. The length of it is, as I said, 90 meter plus 5 plus 5, okay, which becomes 100 meter. And the breadth of it for the inner was 75, so 75 plus 5 plus 5, which is 85 meter. So the area of the outer rectangle is nothing but 85 into 100, right? 8500 meter square. Here also it is meter square. Now the area of the path is nothing but the difference in area of these two rectangles. So which is, let's use this and this, which is the area of the path. pathway is 8,500 minus 6,750, which comes to 1,750 meters square. So the option which shows 1,750 meters square is the right answer.